In our last video, we found the equation of a tangent line to a circle at a point. But earlier in that video, we were able to do the same thing by rewriting the equation as a function on x, rewriting it so we had a y equals. I want to do an example now where I wouldn't have any luck getting y by itself. So in this example, instead of it being easier or possible to use implicit differentiation, I actually have to use implicit differentiation to be able to find the slope of this tangent line, to take the derivative of this and find dy dx. Now, this is actually a fairly well-known equation. It's called the Folium of Descartes. Folium being the Latin word for leaf. And the graph looks like this. Certainly not the graph of a function, right? So implicitly, this graph defines several things, little pieces we could take as functions. And so what I need to do now is implicitly differentiate so that I can find the tangent line going through the point 2, 4, which is right about there. So something that looks like that. I haven't done a very good job graphing the Folium of Descartes. If you look at the link below this video, that link goes to this graph done in GeoGebra, where you'll actually see the Folium of Descartes along with the tangent line we're looking for in this video. What I'd like to do now is implicitly differentiate this equation. So I need to take the derivative of both sides, treating y as a function on x. The derivative of x cubed is 3x squared. And now I need to take the derivative of this middle part. And what I realize is I have a function minus 9x times another function y. This is a product of two functions, so I'm going to have to use the product rule. All right, so the first function, minus 9x, times the derivative of the second, the derivative of y is dy dx, plus the second times the derivative of the first, the derivative of minus 9x is minus 9, plus the derivative of y cubed is 3y squared times dy dx. And finally, the derivative of 0 is 0. What I need to do now is get all of the terms with a dy dx on the same side of the equation. And I need to take all the other terms to the other side. So let's see, I need to add 9y, and I need to take away 3x squared. That's going to leave me with minus 9x dy dx plus 3y squared dy dx equals 9y minus 3x squared. Pausing just for a second here, my next goal is to get dy dx by itself. So I'm going to factor it out and I'll end up dividing by something. But looking at this equation right now, every single term is divisible by 3. So I'm going to divide out of 3. That'll make my work just a little easier as I go through the problem. All right. So now I want to factor out the dy dx, and eventually I'll divide by what's left over. But for now, I think I'll factor out that dy dx and write that on my next board. After I factor out the dy dx, I'm looking at this expression on the left-hand side. And on the right-hand side, I still have 3y minus x squared. Dividing by what's in the parentheses here, I'll get dy dx by itself, and I'll have an expression for my derivative. Dy dx equals 3y minus x squared all over minus 3x plus y squared. That's my formula that given an x and a y will tell me slope, and the x and the y I care about in this problem is 2, 4. All right, so let's see. I got to plug in a 4. That'll be 3 times 4 is 12. X is 2, so 2 squared is 4. And on the bottom, I'll have a minus 6 plus 16. Let's see, that's going to work out to be an 8 over 10 or a positive 4/5. There's my slope. The slope of my tangent line is 4/5. That tangent line is passing through the point 2, 4. I can find the equation of that line. Using point slope, now I just need to distribute and simplify. So let's see, my tangent line. Y equals 4/5 x plus 20/5 minus 8/5 is 12/5. All right, I found the equation of my tangent line to the Folium of Descartes at the point 2, 4. Again, there's a link right below this video that will take you to both things graphed together in GeoGebra.